Welcome all. Today in our lecture, we will understand and try to figure out the circuit analysis techniques. And nodal analysis is one of the most important circuit analysis techniques in the field of electrical and electronic engineering. Hello everyone, my name is Mohammad Idar Islam, lecturer Department of Computer Science and Engineering, State University of Bangladesh. Before jumping into the deep of solving the circuit using the nodal analysis, we have to understand what is node. So the definition of node is very simple, and the definition, it includes that a node is a junction point in an electrical circuit where two or more circuit elements like resistors, capacitors, or voltage source, inductors, they are connected together. So here, this is a very simple electrical circuit. We can see that there are multiple points are circled with the red. So here, what does it mean? Here we can see that 10 volt voltage source is connected with 5 ohm in a point of A. 5 ohm, 3 ohm, and 4 ohm resistors. One point is connected with B red circle. 3 ohm and 2 ampere current source, they are connected in C red circle. So here A, B, and C, since there are multiple branches or elements are connected together, two or more branches are connected together. So therefore, this point creates a junction, and that junction is known as a node. Here you can see that only D point is marked over there. Why? Because here 10 volt, 4 ohm, and 2 ampere current source end part is connected with the 4 ohm. So here all of them are connected. So if I point out over there in that manner that here it is a node, we can say, and that is also a node, we can say. But since that three junctions are connected without any interruption, therefore it is a common node, and that's why we did not actually marked and separately identified these things a node. Therefore, since all three elements or branches are connected here in a common, therefore we declared here or identified this part as a common node. So D is our common node. So this is the very important thing, that before doing nodal analysis, you must need to identify what is the node. I hope you can understood. So now we will discuss about what is actually nodal analysis. So nodal analysis, that is also known as node voltage analysis, is a systematic method used in circuit design and electrical engineering to calculate the voltages at the junction points or nodes of a circuit. So now if I ask you to identify the node voltage of A, B, C, and D point, then you must need to apply nodal analysis. So it will be very helpful for us if we directly apply nodal analysis over there. So now how we can do nodal analysis? So there are some procedure that we have to maintain to apply these techniques to solve the electrical circuit. Let's see that. Here we can see that in the very first step, you have to identify the principal nodes and choose one of them as a reference node. So we will treat that reference node as the ground. So since it's a very simple circuit, here there are three nodes you can see. So 4 nodes that you can see over there. So you have to identify one node as a reference node, and rest of them is the principal nodes that is unknown voltage to you. So here the reference node we will treat as ground, and as we discussed in the earlier classes, that the reference node, since it's a ground, the ground voltage, it will be 0 volt. And the ground that we will identify in our circuit, it will be like these things. So rest of our classes that we will discuss, we will make a common ground, we can use this symbol A, B, or C. For my class, I will use this symbol as our reference common ground. And then in step 2, we have to label the node voltages according or corresponding to the nodes with respect to ground from all of the principal nodes except the reference nodes. And then in step 3, we have to write the nodal equations at all the principal nodes except the reference node. We will not do any kind of equations solving for the reference part, because in the very beginning, since we are declared the ground node, it is actually 0 volt. So in that case, for applying nodal equations, we have to find out the KCL first. As we know, we discussed these things in our previous classes. KCL means Kirchhoff's current law. So there are Kirchhoff laws actually divided into two parts. One is KCL and another one is KVL. For analyzing the nodal analysis, we use the KCL first, and after applying Kirchhoff current law, we will use Ohm's law, which is very simple, that in nodal equations you find out the currents, and for determining the currents you have to apply the Ohm's law. What actually Ohm's law states that the across within a conductor, the current that will flow across this conductor, it will be actually proportional with the voltage corresponding this conductor, that is V proportional I. So therefore we can write these things as equal to V proportional I. Now we can write these things as V equal to IR. So since using the KCL, we already determined the current and we identify these things, we know that current. So how to determine these things? So I is equal to V over R. So since I is unknown to you, and the node voltage that you have to find it out, so therefore that the flow of current will help you to determine this unknown voltage. So this is the very simple part that we have to apply over there. And one important part must you have to remember during solve these things. The thing is that the current flows from the higher potential to a lower potential in a resistor. So here, that when we understood the part of Ohm's law, we have find that the voltage of over a resistor corresponding the current is I, and if the value of resistor is R, so the voltage, it will be depends on that particular 2 point. So actually that voltage we can identify as a VAB, which is mentioned that V, the potential difference of the resistors, is the potential difference of that particular two terminal VA minus VV, which means that VA is the higher potential and VV is the lower potential, which indicates that currents, it will always flow from the higher potential to the lower potential. So after finding out the direction of the current, that the direction that you will identify by yourself, and we will discuss these things in the later, you must need to remember after applying the KCL for finding out the current will always flow the higher potential to the lower potential. So you must need to apply these things correctly for each cases. Otherwise, there is a highly chance that your answer will be wrong. So let's see. We will solve this very simple circuit. What the questions tell us to do, that you have to find the current flowing through 2 ohm resistor of the following circuit. That means we have to find out only the current that is actually going from this to 20 ohm resistor. For finding out these things, you have to use nodal analysis, that is strictly mentioned over there. So if in a question the nodal analysis is already ask you to solve this circuit using the nodal analysis technique, there is no other option. Yes, there is since a very simple circuit, there are multiple options that you can use. You can use mesh analysis as well. But since in the question it indicates and ask you to do the circuit solve part using the nodal analysis technique. So you have no other any option. So for finding out the current across this 20 ohm resistor, we have to find out this particular node voltage. And for finding out this particular node voltage, we have to determine all the unknown node voltage. So let's do it. It's a very simple thing. There is nothing to worry at all. So we will apply the procedure as mentioned before, as according to this step, and then we will find it out how to solve these things. So at first, we can see that here in that circuit, you have to find out the node and you have to labeling out the node voltages. So let's do it. So here we can see there are how many nodes we can find. So let's say this one is a node. This one is also a node. This one is a node. And as I told you before, since 4 branches are connected together, this is our common node. So in that very simple circuit, there are actually 4 nodes. 1, 2, and 20 ohm, 4 ampere, and 10 ohm. These 3 branches are connected together, so they are common node. So right now, first of all, that in the step it shows that you have to level it. So let's level it. There is a one thing I have to told you, that since this particular node is directly connected with 20-volt voltage source, therefore this particular node voltage, it will be 20 volt directly, since 20 volt is an independent voltage source. So therefore we do not need to find out that particular node voltage separately. So it is a very important thing that you have to understand. Okay, otherwise there is a highly chance that you will miss the question answer properly. So therefore, if any node is directly connected with the independent voltage source, then you will identify that node as a voltage source value, except super node situation. So what is super node? We'll discuss these things in the later classes. So there is nothing to be worried at all. So now identify these things as node 1, node 2, and since this is a node 3, that is our actually common node, we are identifying these things as ground. Okay, so this is our ground, and we know this voltage is actually ground voltage is actually 0 volt. This is the first part that you have done. You level the voltage node, and now you have to level the voltage, right? So the voltage in V1 node, we will write these things as V subscript 1, V subscript 2. One thing you have to remember when leveling these things, I am doing in that my way. You can level this 1, 2 according to your convenience. You can write these things A, B, or X, Y, whatever it is. So I am doing in my way. You can do it your own choice. So there is nothing, blindly you need to follow. So this is the way I actually leveling this part. And after doing these things, for each node, you have to find out the nodal equation. So this is your node 1, this is your node 2. So I will write these things here like that. At node 1, applying KCL. So at node 1, we have to apply the KCL. So how we can do these things part? Let's see. Before doing these things, you have to determine the current direction. Without this, you cannot do this math. So let's do it. Here you can see that current is flowing from 20 volt sources here, and I am identify these things as I1. The current must need to pass from there. I am writing these things as I2, and this is I3, and let's say this is I4, and this is I5. So now you may ask the question that since I am identifying this current path according my own convenience, if you do in another way, what will the results alter or change? No, but you have to do in the consistent manner. Like now I am for V1 node, I am considering that I1 current is entering the node and I2 and I3 current leaving the node. That means according to the KCL, what does it says that outgoing and incoming current summation for a particular node, it will be equal to 0. That means out for a particular node, outgoing and incoming current, it will be equal. So now for V1 node, I am considering that I1 current is entering in V1 and I2 current and I3 current are outgoing current for the V1 node. Let's say for V2 node or 2 node, if you consider again these things and rearrange the current direction, that I3 is outgoing, that means for V2 it will be outgoing and it will be incoming for the V1, and I4 it will be incoming for the V2, then it will be change your results and it is a wrong assumption. So in the very first, when you directed the current path, then you will never change these things for the other node. So you have to remain consistent. And one thing you have to understand, why I have directed I5 as the incoming current towards the node 2, because of the direction. So I cannot write these things like that because already that current is directed over there. If you want to direct it I5 in the opposite direction of V2, then you need to write minus 4 ampere because the direction is already provided to you. So you cannot change it. So if you want to change the direction, that you have to write the negative value in front of that 4. I hope all of you have understood. So now the direction of the current, since it is done, let's do the math. For the node 1, we will apply the KCL. So let's say for the V1 node or for node 1, we see that I1 is incoming current and I2, I3 is the outgoing current. So as from KCL, we already understood that incoming and outgoing current will be equal for a particular node. Therefore, we can write over there that I1, it is incoming current for node 1, and I2 and I3 current, they are outgoing current for node 1. So therefore, let's say I'm just identifying these things. This is your outgoing current, incoming current. And this is your outgoing. So now we actually here apply the KCL, right? It's a very simple thing, but very crucial to understand, right? So then we have to apply the KCL. You have to apply the Ohm's law. So let's do it. What does it says? The current I1, it is going from the higher potential to the lower potential. So higher potential is V high here and lower potential is V1, right? So I1, it will be 20 minus V1. Why I'm not writing over there V1 value? Because V1 is unknown to me, right? We have to find out that value. Therefore, we are doing this nodal analysis, okay? So since it's unknown to you, write it as variable. We will solve this equation, okay? And the current is actually passing through 5 ohm, so divided by 5. And then for I2, the current is going from V1 to the ground. As we know, the ground voltage is equal to 0, therefore we will directly write over there 0, and it's passing through the 10 ohm resistor. And I3, it will be V1 minus V2, because V1 we are considering this is as a higher potential, and it is going through the 10 ohm resistor to the towards V2. So write it. So V1 minus V2 over 10. Now you have to simplify these things. There are many options that you can simplify. So let's write it. So 20 over 5 minus V1 1 over 5 and V1 1 over 10 plus V1 1 over 10 and minus plus V2 1 over 10. Since one thing I have to told you that this is actually Ohm's law that we apply these things over there. One thing you have to understand, since we have the access of scientific calculator in our exam hall, so there is nothing to simplify it more. So you can directly put this value into the calculators and you can solve up to 5 or 6 unknown voltages or values of simultaneous equations. That means 6 simultaneous equation or at least 4 simultaneous equation you can solve using the scientific calculator. So there is nothing to do more simplification except finding out the variables separately. So let's do it. I'm just taking this V1 in that part and rearranging this like that. 1 over 5 plus 1 over 10 plus 1 over 10 and V2 is equal to 1 over 10. It will be minus. Okay, since I'm common plus V2 over there. So plus minus, it will be minus. Minus 1 over 10 is equal to 4. And this is your number equation 1. Okay, so how we can solve it using the calculator, I will show these things to you later. Okay, so now our first part is done. And the second part is that you have to find out the nodal equations for node 2. So at node 2, again, we will write at node 2 applying KCL. Applying KCL. So let's see here which current actually entering in node 2, I3, I5. These are the incoming current, right? I3 and I5, and outgoing currents, that is I3. So here I3, sorry, I'm writing wrong over there. Okay, it will be I5, I4. Okay, so I3 and I5, this is actually your incoming current. And this one is your outgoing current. Now solve it. How we can do? Again, it's a very simple. We will just simply apply Ohm's law. So here in the node 2, I3 is incoming. So that means it is coming from V1 to V2 through the 10 ohm resistance. So let's write it. It will be V1 minus V2 over 10 ohm. And I5, that is directly given 4 ampere. Nothing we need to do over there. It's a very simple thing. Okay. 4 ampere. And I4, it is going through this 20 ohm resistance from V2 to ground. That means 0 volt. So V2 minus 0 passing through 20 ohm resistor. Now we will solve it. Let's put it in that part. V1 minus V2 over 10 minus V2 over 20 and put that 4 in that right hand side. Since the side is changing, the sign will be changed. From plus it will be minus. Now make the variable common. So V1, we can write these things 1 over 10. And for plus V2, we can write minus 1 over 10 minus 1 over 20 and equal to minus 4. So this is the second equation we have find out. One thing is very interesting that you have to understand how many nodes there are. There are actually 4 nodes. Already one voltage you know. So there are 2 unknown voltage. And that node's voltage you know. Therefore, since 2 unknown voltage you will get, therefore 2 simultaneous equation you will find with 2 unknown variables V1 and V2. You have to find it out. Let's say you have 5 equations, 5 nodes. Let's say 5 nodes, and among them 4 nodes is unknown, and among them one is actually your reference node. Therefore, the unknown voltage, it will be 4. So for nodal equation, the unknown voltage will be always n minus 1. where n is the number of node and 1 is actually reference node. So if there are 6 nodes and one node you will identify as your reference node, then 4 nodes it will be unknown to you. So for our case, see, though there are 4 nodes, one node is our reference and one another node's voltage we know. Therefore, we will get two simultaneous equation. So let's see how to solve these things uh, using nodal analysis, using the scientific calculator. So I have to clear all that drawing. So here we can see that this is actually your equation. So here we can enter that two simultaneous equation and find it out what is the value we can get. So at first you have to go that menu option, and here you can see that solve systems of equation with two unknowns. We can solve up to 6 unknowns. So for our equation we have two unknowns. We will put the value over there. So for equation 1 that we have gate, that is 1 over 5, then plus 1 over 10 plus 1 over 10. Okay, so this is for V1, and your here X is actually V1 and Y is V2. That means X is node 1 voltage V1 and Y is node 2 voltage V2. And then go for this part. It will be simply minus 1 over 10. 10, and this part will be equal to 4. And now that equation 1 value we entered over there, we did not we did not complete any kind of further simplification. We just put the variables value over there. Since we have the access of scientific calculator, so therefore we can simply use it. Okay, so then another part, it will be another equation for V1. It will simple 1 over 10, and for V2 minus 1 over 10 equal to minus 1 over 10. And in that C part, it will be again, I did mistake over there, it will be 20. And here it will be minus 4. Now just simply for solving these things, you can write equal or solve part. So here we can get the X value as 20 and Y value is 40. That means that the X, since we get from the equation X we get V1 is equal to 20 volt, and Y V2 that we get as 40 volt. So this is our V1 and this is our V2. And the current passing through this 20 ohm, it is nothing. That was I4. That means I20 ohm, which is, we solved earlier, V2 minus 0 over 20. That means we can simply write 40 over 20. So we can cut over these things and it will be 2. So since the value is in ohm, therefore the I4 and I20 ohm, it will be 2 ampere. And this is your answer. So using this technique, nodal analysis, we can find out the value of each node voltage, and that is our first part. And in the next class, we will do we'll see how to do the nodal analysis technique, how to follow the nodal analysis technique if there is a voltage source between the two nodes, and that is known as the super node. We will see in the next class. And thank you all for watching this lecture series and that lecture tutorial. Thank you all.